Hello, 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 it's Mr. Pearson here, and today our lesson is about decomposing wholes and partitioning number lines. So, let's say decomposing. We know we could decompose 10. It's the same thing as 5 plus 5, or we could decompose 10 and say it's the same thing as 9 plus 1. But what if we just have 1? How could we decompose just one whole? Well, you could decompose it into fractions. You could decompose one whole into a half and a half, because 1/2 plus 1/2 is one whole. 1/2, 2 halves are equal to a whole. And so here's an example. Here's a half, 1/2, another half, all together, it's a whole. What about, I want to decompose one whole into thirds. How many thirds do you think it would take to equal one whole? If you said 3/3, I think you may be right. Let's see. 1/3, 2/3, 3/3, and a graphic representation here. All equal size fractional units. 1/3, that's not the whole thing. 2/3, still not the whole thing. 3/3, that's the whole thing. Somebody had a great question. They said, do you write it like 1/3, 2/3, 3/3? No, you do not do that, because each fractional unit is 1/3, so it's 1/3, 1/3, and 1/3, because each unit is 1/3. How about fifths? What if you have a whole and you want to decompose it into fractional units? How many fifths would it take? Okay, welcome back. What do you think? How many fifths? Well, let's see. I'm going to make a rectangle this time. It's easier for me. 1, 2, 3, 4, 5. How many fifths would it take? The denominator is 5 to make one whole. Let's see. 1, 2, 3, 4, 5. 1/5, 2/5, 3/5, 4/5, 5/5. Each of these is 1/5, 1/5, 1/5, 1/5, 1/5. Now let's decompose it. The number bond. 1, 2, 3, 4, 5. Now you should be noticing something about all of these wholes. This is 2 out of 2. This is, well, that should all be 1/3. 1/3, just like I told you to do before. Whoops. All these wholes together equal 3/3. So, 3/3, 2 halves, 5/5. What do you notice about the numerator and denominator in these fractions? That's right, they're the same. When the numerator and denominator are the same, it equals 1. One whole. So you could say 2 out of 2 equals 1. And 1 is the same as 5 out of 5, which is also the same as 3 out of 3. They're all one whole. Okay, now let's talk about partitioning a number line. Say you have 0 to 1, and you want to separate that into halves. A lot of students think that you need to make 2 lines because you're cutting it into half, and that's 2 pieces. Actually, you don't need 2 lines. However many pieces you want, you need 1 less line. Say that again in your head. However many pieces you want, you need 1 less line. So if I want 2 pieces, I need 1 less line. That means I need 1 line. See how there is 1, 2. Now there's 2 pieces. And if I go here, right here is half. Now I've partitioned this line into halves. This would be 1/2, and here's 1, which we just discussed, is the same as 2 halves, 2 out of 2. What if I want to partition a line into thirds? Well, we know thirds would be 3 pieces, and I'll need one less line than 3. 2. Whoop, that's not quite right. Those are not equal fractional units. I want to make sure that each unit is the same. Yes, that's a good approximate size. And remember, goes over top of the line. 1/3, 2/3, 3/3. Here we do increase the number size because we're increasing the distance. Just like you would on a ruler, go from 1 inch to 2 inch to 3 inch. Now we're increasing the distance, 1/3, 2/3, 3/3. And last one, I'll let you really think about this. Fifths. How many lines would we need to draw for fifths? If you thought 4 lines, you're right, because the number of lines is 1 less than the number of pieces. Let's see, I'm going to try to make it equal fractional unit. All right, yeah, equal fractional units. 1, 2, 3, 4. So they're about the same size, and let me just check to make sure I have 5 spaces. 1, 2, 3, 4, 5 spaces. Good, so here's 0. Here's 1, which will be the same as 5 out of 5. And we travel a distance, so we do count higher. 1/5, 2/5, 3/5, 4/5, 5/5. Now you have an activity to do. Best wishes. Thanks for your attention. Have a great day. Mr. Pearson, over and out.